everyone! Kiera, Cindy, and I will be sharing what we've learned about 3D printing within and beyond fashion design. Let's get started! 3D printing, also known as additive printing technology or additive manufacturing, again, creates complex and detailed objects by building thousands of thin layers upon each other with speed and accuracy, which reduces waste. 3D printing's benefits are evident in rapid prototyping for testing and small-scale manufacturing. 3D modeling software such as Tinkercad and Bamboo enable designers to easily and quickly make changes to the design compared to traditional methods of manufacturing, such as welding or casting from a new mold. Depending on the 3D printer, the end use, and other factors, a wide variety of materials can be used, including but not limited to plastic polymers, metals, ceramic, concrete, and more. The three main 3D printing techniques were patented in the 1980s when innovators began to experiment with the earliest 3D printing techniques. Dr. Hideo Kodama was the first person to describe a layer-by-layer approach for manufacturing in 1980, which became the predecessor to stereolithography, aka SLA. This is using a UV light to polymerize a photosensitive resin or to group the resin together into large molecules. Other engineers also began to experiment with developing 3D printing technology. In 1988, the first SOA and SLS machines were sold commercially. SLS, short for selective laser sintering, is another 3D printing method in which powder grains are fused together locally by a laser. Last but not least, Scott Krupp filed a patent for fused deposition modeling, FDM, which is melting plastic filament through a nozzle to build objects layer by layer. This is most familiar to the general public when we think of a 3D printer. Leading up to 2025, 3D printing has been used in creating replacement organs, bones, and prosthetics, automobiles, food, housing and buildings, clothing and textiles, and more. Some key filament types for clothing and textile manufacturing include polylactic acid and thermoplastic polyurethane, abbreviated as PLA and TPU. PLA is the most commonly used 3D printing filament for its strength, low cost, and versatility, making it easy to print a wide range of objects such as food-safe kitchen tools and home organizing gadgets. In contrast, TPU is more flexible than PLA while also having great durability and abrasion resistance. Items such as phone cases and software panels are commonly printed from TPU. However, TPU is harder to print than PLA, and the school's printers only print PLA. Therefore, all of our samples will be printed using PLA filaments, including applications where TPU would be more suitable, and we will talk about that.
When thinking of 3D printing as a concept of turning a 2D-ish filament into a 3D object, it's really not so unfamiliar. Yarn work is quite similar in its process of taking a continuous piece of string and transforming it into a garment or object. Same with wire work and soldering. These all practice a form of production known as additive manufacturing. On an even smaller scale, you could consider acrylic nail art as additive manufacturing as well. One brand practicing additive manufacturing in fashion is the Spanish brand Zur Collection. They create futuristic, functional, and urban clothing with sporty aesthetics using IDX technology in their BCN 3D Sigma 3D printer. They first digitized their patterns all in Clo3D before sending them to the printer to be extracted precisely. The machine enables them to print two fabrics simultaneously, combining different materials to achieve customizable properties such as stretch and thickness. This process produces only what is necessary. Not only that, but used garments can be melted down to reproduce filament. As a result, the design process is almost entirely zero waste. The flexible TPU filament gives them complete freedom to play with different textures, shapes, and applications. The first designer that comes to mind when thinking about 3D printing in fashion is the iconic Iris van Herpen. The Dutch fashion designer known for her inventive use of technology in fashion couture printed her first 3D dress back in 2009. The skeleton dress, which she later showed in her fall 2011 Capriole collection, used a technique called selective laser sintering, which involves an enclosed environment filled with nylon powder and nitrogen gas. A leveling arm continuously distributes the powder evenly on a bed, while a selective laser melts the powder into its specific shape. This creates a highly detailed, dynamic print without the need for support structures or extra material to be sanded off. Another technique Van Erpen employs is 3D polyjet printing. This is a kind of resin printing that eliminates the need for a hazardous tub of liquid resin. The foliage dress, printed with this technique, was presented in Paris as part of her 2017 Ludi Naturae Oak Tour collection. Using Stratasys polyjet technology developed by TU Delft scientists with capabilities to print different materials simultaneously. It was printed directly onto 0.8 millimeter tool and attached separately by hand to the dress form. This is known as the 3D applique technique. While researching, I came across a few social media accounts from companies that specialize in manufacturing 3D applique pieces for designers. ABI 3D is a company that can take any conceptual idea and work with the client to design and print their desired 3D fabric design. They work with a variety of filaments to create different effects. There's even an eco-friendly material called Vero Eco Flex. There are several accounts like this. At Kaizen 3D Prints is an account I found on TikTok. He specializes in pretty much the same type of 3D applique, but he prints on a holographic bed to give his designs a beautiful rainbow iridescent effect. There are so many more applications for 3D printing in fashion out there. For example, Aaron Robertson, a Boston-based designer and former winner of Project Runway, worked with Chinese grad student Jifei Oh in 2019 to create Cilia, a jacket made with biocompatible 3D printed resin fur, supposed to feel like mink or chinchilla. Or designer Robert One working with London-based 3D artist Yuma Burgess to create his surrealist arm sculptures for couture. The possibilities for 3D art are quite literally endless.
"3D printing can be used to create things like furniture and packaging materials. The materialized sketch chair was created using a non-physical pen to sketch the chair. This works from motion capture technology to record a three-dimensional design of the finished object, which is then captured as a digital file. This file was then fed to a 3D printer, usually used to make parts for racing cars, which built up the chair layer by layer using a liquid ABS-like resin strengthened with tiny particles of ceramic. For the Anji vases, the designs were made on a computer before printing them out using a 3D printer, where they adjust the nozzle to accommodate the iron-rich clay from which the vases are made. In shipment packaging, the 3D printer is used to create certain patterns that are flexible and can expand when being moved or pulled. It's often used in shipping products like glass or bottles. 3D printing could also be used in bicycling, armory, and prosthetics. 3D printing technology made it possible for bike manufacturers to develop a number of versions of the handlebar in preparation for racing. Each design iteration optimized the rider's ride position, reducing aerodynamic drag. Another example in bicycling is the power saddle made in response to the discomfort of riding a bicycle for an extended period of time. For armory, in 2013, Cody Wilson exploited 3D printing technology to make his own gun and shared the STL files to make it, but quickly after was ordered to remove the files by the US government. In 2021, Open Bionics developed the Hero Arm, which is an affordable multi-grip 3D printed prosthetic arm. The process involves taking a scan of an individual's arm, which is 3D printed to create a uniquely customized limb. The first sample is 3D printed flexible fabric, and this is the reference. On Tinkercad, I first added a triangle onto the mat and adjusted the size and height of the shape, and did the same thing for the red rectangles. After putting the shapes together, I copied and pasted that to create a repeated pattern. When it's done, it should be downloaded as an STL file and opened up in Tinkerine Cloud, where the structure can be adjusted. After pressing slice, you can also see the order of how it's printed and how long it will take. The first sample was really stiff and wasn't moving how we thought it would. We thought that maybe the height of the rectangle pieces that hold the triangle pieces together was what was causing the stiffness. So for the second sample, the height of the rectangles were adjusted to be even thinner, hoping that it would make the fabric more flexible. The second sample had more movement than the first sample, but it still didn't move how it's meant to be. If the height was adjusted to be any more thinner, it wouldn't print properly. We ended up concluding that it was because of the PLA filament that we used, and that if we were to use TPU filament instead, it would have moved the way it was supposed to. But since the school printers don't allow TPUs to be used on them, it wasn't possible to get the outcome that we wanted.
For my sample, I really wanted to try the idea of 3D printing on fabric.
It's gonna first travel here, then it's gonna come here, then it's gonna come here, and then it's gonna come here.
Nicole was able to give us a thorough demonstration on how to use the Ditto Pro 3D printer.
Lowered. So look, this one is like super loose. So I'm gonna raise the bed in this corner. I don't think so. But really, does it need to be visible on the other side?
After my first successful attempt printing on mesh fabric, I decided to go ahead and try a scale pattern I found on Thingiverse. All my team members have abandoned me, so I'm on my own.
I have that on recording.
Give myself a lot of wiggle room in case of the please. Yeah, exactly. So what, maybe?
The mesh was slightly ripped when removing it from the bed, but still I think it was a pretty successful attempt. Now, I really wanted to try to do a design completely from scratch, create the 3D model myself, and then try printing that on fabric. So I decided to do something simple and start with the dot pattern. I found this star pattern. It's very popular as to send in text and stuff, so I just uploaded a photo of it to Adobe Illustrator and manually traced out all the dots and created the entire design as a vector image. After my design was finished, I saved it as an SVG file and was then able to upload it onto Tinkercad, where I can change the size of the print and the height that the print will be. When I was happy with the dimensions, I saved it as a STL file. This design I printed on the Bamboo Lab printer instead of the Ditto printer. It's a more precise printer with a thinner nozzle and more cleaner finishes. So once the file is uploaded into the Bamboo Lab app, I'm able to play with the slicing, how much infill is going to be in the print, whether I want it as a grid or as a hexagon or triangular infill. And once it's sliced, I can choose actually the second layer and add a pause to the print, and this would be the time that I would insert my mesh fabric to be sandwiched in between the print. Two.
P1S, and then it's a 4 millimeter.
4 millimeter. Okay.
Point four. Yeah. And
like not to understand what worked. Yeah. I thought like I just looked at this. I was enjoying it. It was hard, but I was enjoying it. Yeah. The beginning.
Great.
Hello, welcome to Thingiverse. This is an open source platform where you can look for 3D modeling / 3D printing designs, as well as make your own. So on the top bar, there's an Explore and a blog where you can look for 3D modeling or 3D printing designs you customize or discover other creators, discuss other techniques or with other creators, etc., as well as Thingiverse Education for free lessons. So, for example, let's say I want to look up the kinematics bracelet that we are 3D printing, which is this file. So when you want to download the file, you can go down to Files and click Download All Files, and this will show up as an STL file. Another cool thing to do on Thingiverse is to make changes to another person's design, but obviously it credits them back. So this file by AK Eric, it is a remix from another creator, which is, well, nervous system. But they're like different shapes. And you can also preview what it looks like in the modeling view. And there are also pictures of how it will look like when printed out that creators often post. So for thing details, you can see often a summary, instructions, tips to have successful print, files on where to download, comments from everyone on the internet, and for people who are not the original creator, they can print it and share, kind of like a review section when you go online shopping, as well as the remixes to put your own spin on what's already been done, as well as app recommendations to do those remixes. So yeah, that's a quick overview of Thingiverse, and I hope you enjoy it and get to use it at some point. Last but not least, we have a textile formed by interlocking 3D printed pieces. This 3D printed bracelet is inspired by the kinematics dress made by the company Nervous System, where they 3D printed a dress made of small pieces joined by hinges without having to connect each piece individually, and they all print in one go. This bracelet file was created by user AK_Eric on the open source platform Thingiverse. Platforms such as Thingiverse and Tinkercad allow users to post their 3D modeling files online, download files shared by other users, and to duplicate them to edit for personal use. When previewing a file for 3D printing on a computer, you can verify how you want solid pieces to be filled, such as with a grid pattern, the amount of filaments and time you'll need, how the printer nozzle will move as it prints the objects, and more. Make sure your object size fits within the bed dimensions of your printer. And the joints are like printed so you don't have to connect them one by one. And this pattern or model has its own hinge, so you can boop and wear it. I've been thinking about the applications of the kinematic textiles, like with the hinges, beyond the dress, and it's perfect for the dress because it conforms nicely to the body, kind of like the dress form here. But what about other applications? Well, I'm also thinking about how with the technology to print one piece completely within a small-ish 3D printer, the piece has to like fold over and conform. It could make a nice application for, say, a lampshade. Imagine like the upside down kinds, because if you were to make it out of a traditional fabric textile, you would have to probably have some fabric waste cut off to get like the angles, because it's narrower on top and bigger on the bottom. But with, say, the kinematic textiles type of 3D printing with the hinges, not only can it be a flexible textile that could also fold over on itself while printing, it can also reduce material waste. Thank you for listening. We hope that you've enjoyed learning about 3D printing with us and that it's added to your ideas of clothing and product manufacturing. Aha! Kiera wants to use this for her final collection. Thank you so much. Bye!